Welcome to this rather odd video. Normally I generally do gameplay videos and opinions, but I also am in the process of really learning how to program. In this video I'll be going over how I made a program or made a function that allows me to check if I am inside a triangle in processing, which is a set of functions for Java, which I probably didn't need to explain because if you are here you probably searched for help exactly with this. So let's get into it. So I made this fun program that allows me to make points and then select those points to make triangles. The complicated part is, how do you detect if your mouse is inside a triangle? Because I managed to be able to highlight it, and it is extremely exact, which was something that I was not able to manage in previous versions, which is why I'm so happy with this version. Now, I'll be going over first why this is so difficult, and then I'll explain how I did it. For that I won't be using my program though. I'll be using another fun program, which I haven't downloaded the full version of, which is GeoGebra. Or GeoGebra. I don't know which language you want it in. Now, this is basically the same situation. I have a triangle, so 3 points, A, B, and C, and then the mouse point, which I can just also drag around. Now, I have thought up a lot of different ways on trying how to do this. The easiest way I thought was do it with angles, because you have the angle for all corners, and then you also of course have these angles. Now this would present an extremely easy way to do this, because, well, look at the angles. Currently, they are all 120, or at least around 120. When I drag them towards here, 2 of them go up a bit, and 1 of them moves down. But once I go outside, a funny thing should start appearing. One angle is always above 180 degrees. And here we are running into a different problem, which I'll quickly go over, but the first solution that I tried was, can I check if one of these angles is larger than 100 and is larger than 180? Is larger than a straight line. Of course, that kind of runs into the problem if you have a triangle like this. But of course, now the fun part is, each one of these corners is above 180. And if you drag it outside, one of them will be lower. So, if I can calculate this corner, then I am able to do it. Now, this was already remarkably complicated actually. Processing doesn't naturally have a way of finding the corner between 3 points. Now, what I was able to do is use the cosine and the distance of these 3 lines to find this angle. But of course that runs into a problem. Because, well, the thing here was, for instance, if I'm looking, normally I'm looking, this corner is between C, M, and A. Here, between C, M and A, is this entire part. But of course, when we use that cosine, or actually it's the A cosine, it's the inverse of the cosine. But when we use that, we always get one of the corners on the inside, meaning it will never be above 180. Now the problem with that becomes this trick. We can't use this trick anymore. And I tried a whole lot of things and none of it was even remotely close to working. Then I realized I was looking completely at the wrong angle. So we scrap these. We scrap these angles. These angles, we can't use them. They are just always a value that we can't really calculate with. What we can do something with is the corner BMC, which is in this case a part of BCA. And some of the more clever people out there probably already figured out exactly what I'm going to do. If I'm dragging this one outside, then BCM will be bigger than BCA. But then you'll think, oh, but what if you drag it outside here? Because, yeah, sure, now this goes all the way around, but you just explained that it will always take the smaller one, so it would just take this little bit. Which is very true. But in that case, ABM will be larger than ABC. And no matter what, this will always work. So that's the thing we are going to need to find. We need to be able to find the angle CAB or ABC, doesn't really matter, we need all three. And we need the angle ABM. Now, we are not done yet, because we may have found what we need to find, but we haven't found how we find them just yet. This is where we go back into the programming. This is the code that I use. It's a bloody nightmare. Alright, this code is specialized for my program, which is slightly big, so most of this you don't need to worry about. All you need to know is that in this triangle array list, I store triangles by using a three-dimensional float array. What it really just means in this case, but all of that is unimportant, because just here I basically just enter what coordinates it has into A. All that it basically says in A in this case is, for instance, 0.10. That's all that it says basically. In A has an x coordinate and a y coordinate. Of course, the calculation we are going to need doesn't rely on those points. It doesn't care where those points exactly are. To calculate these angles, what we need to find is these distances. And that I do here. I get the distances of AB, BC and AC. And I do that with the function calculateDistance. If only calculateDistance was a thing. Maybe it is, but I couldn't find it. So I had to make it myself. Don't worry though, it's an extremely easy piece of code. Literally all that we use is a squared plus b squared is c squared. In this case, a squared becomes this part. mathpow, which just does the square part of the distance x1 minus x2 is a. And it doesn't matter if x2 is bigger than x1, because we're going to square it. So this could just as easily say x2 minus x1, it doesn't matter. Don't worry about it. This just calculates how far the two are apart from each other. Then the basically a has to get squared. We do that with mathpow, then what needs to be kind of powered, and then by what it needs to be powered. So it needs to be squared, so mathpow a 2. Then we do the same for b, and in this case we put in the y values. So now we have a squared plus b squared. Now that equals c squared. So to get c, we simply take mathpow and power it by a half, which is just the square root. So this is just the very simple code to get from two coordinates to the distance between the coordinates. So we calculate the distance AB, BC and AC, and then we also calculate the distances AM, BM and CM. Then the complicated part begins, because then we start working with calculateAngle. I have spent multiple hours looking if there was a simple code for this. There wasn't. So instead what I ended up using was some of the standard math for triangles, which everybody knows they had known, but nobody knows anymore. I'd rather not say how long it took me to basically find this function again, but the function we will be using is cos c, where c is the angle we are looking for. It's a squared, which is one side that is adjacent to c, plus b squared, which is the other side adjacent to c, minus c squared, which is the opposite side, and all of those are the length of those lines, divided by 2ab. Luckily we already have those sides. We can simply use mathpow on the side 1, 2, where on the side 1 is just a, mathpow 2 makes it a squared, plus mathpow on the side 2 squared, which is b squared, minus mathpow opposite side 2, which means minus c squared. Now don't forget to put this entire thing in brackets, because if you don't, things will start to break. And this part definitely needs to be in brackets, because if it's not, things will definitely break. That was one mistake I had made and it costed me way too much bloody time. So this simply becomes 2 times on the side 1, which is a, times on the side 2, which is b. And because that equals cos c, so the cos of the angle we are looking for, we simply use math.acos, so the inverse of cos, over the entire thing to make it the angle we are looking for. So then we can calculate the angle of ABC, BCA and CAB, and also ABM, BCM and CAM. And then just the simple part starts. Simple if statements. Simply if ABM is smaller or equal to ABC, then we can progress to the next step. If BCM is smaller or equal to BCA, then we can once again continue to the next step. And then if CAM is smaller than CAB, we can finally do the thing that would happen if we are in fact inside the triangle. Thank God, we have found it. This is the code that I used to find out if I am in fact inside a triangle where I know the 3 points of that triangle. And I only needed 2 other functions to really do it, where I also had one minor different function that allowed me to put in the float array like I have A, B and C stored in. Now I'll also just have all of this code in the description, and this entire program will be downloadable somewhere as well. But you can only really use code if you know what the fuck it does. So hopefully this will help you in whatever endeavor you have with finding out if you are in fact inside of a triangle. I hope it helps. Let me know if this tutorial was even vaguely useful. I am recording this at 1:15 AM, so sorry if it sucks. This has been Phoenix, saying farewell.